We are starting with 6-2 multiplying monomials and factoring monomials. So first question, how do I multiply a polynomial by a monomial? So how do I take a one-term thing, a monomial, and multiply it to a bunch of stuff? We are going to distribute, like we normally would, that one term, or the monomial, to every term inside the parentheses, like we always do with distributing. When we do this, we will multiply the regular numbers, so multiply the coefficients is the vocab word for the number that's in front of a variable, and we will add the exponents on the variables. So let's take a look at what this will look like. Multiply the coefficients and add the exponents of variables. Our first example, 5n multiplied by a whole polynomial in parentheses. I'm going to draw my arrows to show that I'm distributing. If I do 5n times 3n to the third, 5 times 3 is 15, and an n times an n to the third would give me an n to the fourth. I'm adding that first n has an exponent of 1, second one has 3, so it turns into 4. Next term, 5n times negative n squared would give me negative 5n to the third. N times n squared is 3n's, or n to the third. Then 5n times a positive 8 would give me positive 40n, and that would be my new polynomial. The next question says, how do I factor the greatest common factor out of a polynomial? So this is what we were doing in our investigation last week. We are going to find the greatest or the largest number and variable. So I'm going to abbreviate number and variable. You could divide from every term and write out front. So find the greatest number and variable you could divide from every term and write it out front of the parentheses. So if we look at our example, our first one, 9x to the fourth plus 45x squared minus 18x. If I'm thinking about numbers first, all three of those terms are divisible by the largest number possible would be by 9. So I'm going to divide them each by 9 and write what would be left over. So if I take a 9 out front, then what would be left inside would be just 1x to the fourth. So I'm going to write x to the fourth. 45, if I pull out a 9, then I'd have 5x squared. And negative 18, if I divided by 9, would leave negative 2x. So remember, factoring is like undistributing. So I basically made it look like what it would have been before you would distribute the 9. Now I need to think about if there's a letter that they have in common, and they do. They all have at least one x. So I can take one x out and I would just write it by the 9, so it said 9x out in front. If I had x to the fourth, but then I pulled out or I divided 1x, now I'm going to have x to the third. 5x squared divided by 1x would leave me just 5 and 1x left. And negative 2x divided by x, if I pulled the x out, I only have negative 2 now. This is my answer. Written like this, I have factored, I have undistributed as much as I can. There's my answer. Looking at the next one. The largest number that I could take out from this would be 8. All three parts of that are divisible by 8. You could pull out a negative 8, or you could pull out of a positive 8. It's up to you, depending upon what you want that first term to look like. I think I want my first term to be positive, so I'm going to pull out a negative 8. That way, when I divide negative 72 by negative 8, I get a positive 9, and my letters are still in there. Positive 32 divided by negative 8 gives me negative 4u squared. and negative 56 divided by negative 8 gives me positive 7u. Then I'm looking at the letters. They all have at least one u. There's a v in one spot, but not in any of the others, so only one u is in common. So now I'm going to say negative 8u out front. If I take away a u from the first term, if I divide it, I have 9v to the fourth left. If I divide a u from the middle, I have negative 4 with 1 u left. And if I take away 1 u from the back, I only have positive 7 left for that term. The last question here says, how do I factor the GCF from a polynomial? That's what we just did. So I think I accidentally repeated our questions over here in the question column. Same thing for both of these. So I'm just going to write that that's the same and move on to the back. We're going to practice a few more times on the back, factoring out the greatest common factor, the number and letter that they have in common. And on the back, what's different is we need to make sure our answer is in standard form. So I'm going to write over here as a note to myself, double check standard form. Remember that that means that the term with the highest exponent should be first, and then it should decrease as we go across. So if I look at my first example, I'm going to zoom in a little bit. I'm looking for a number that they have in common, and if I look, the biggest number they have in common would be 6. They have a 2 in common for all of them. Looks like they all have a 3 in common, but the biggest one would be 6. So I want to divide them all by 6 and pull it out front, undistribute, and what I would have left would be 6n plus 7n squared minus 2n to the third. Divided each number by 6. Now I'm looking at the letter. They all have one n at least. So I get to pull one n outside. Then 6n, if I take away the n, just has 6. Positive 7n squared, if I take away an n, is just positive 7n. And then if I take one n away from our last term, I have negative 2n squared. So I've taken out, I've factored correctly, and I need to make sure now that it's in standard form. So I would rewrite this with my GCF, my factor out front, and then negative 2n squared plus 7n plus 6. And that would be my answer, fully factored. If I look at the one next to it, the number they have in common is also 6. So if I take a 6 out, I'm going to have 3xy squared plus 2x squared y squared plus 5x7 y2. Now I'm looking at what letters they have in common. These all have x's and y's, so I'm going to go one at a time. Let's start with x's. They each have at least one x, so I can take one x out. So I'm going to write 6x out front. If I do that, the first term doesn't have an x anymore, so it would be 3y squared. The second term would lose an x, so it would be 2x y squared, only one x left. And the last term would be 5x to the 6 y squared. I took away one x, divided it away. Now I'm looking at the y's. They all have y squared, so I can take that out. 6x y squared would go in front. And if I look, I have just a 3 left for the first term. I would have 2x left for the middle, and at the back I would have 5x to the 6 left. Last thing is I need to make sure this is in standard form, so my monomial that I pulled out, the factor stays in front, then I reorder the polynomial inside. So 5x to the 6 plus 2x plus 3 would be my final answer for this one, fully factored. Our next one, we're doing the same thing. It just has a little bit more parts, a little bit more complicated, but we can handle it. Looking for a number that would divide all of these, the biggest number possible is going to be 9. So I'm going to take a 9 out first. I would have 10, A10, B5, C3. Then I'd have 6, A3, B10, C. Not changing any of the letters, just the number. 6, A3, B4, C3, and 9, A4, B5, C. I'm going to switch colors and look at the letters now. I'm going to look at A first. The first one has 10 A's, second has 3, third has 3, last has 4. So the most A's in common are 3 A's. So everything has 3 A's. I'm going to pull that out front. So first term used to have 10. If I take away 3, now that has 7 A's, same number of B's, same number of C's. Middle had 3. I took out 3, so it has no A's left. So just B10C. Third one also had 3. I took those all out front, factored them out. So 6B4C, 3 left. And the last one had 4, took out 3, so it has 1 left. We're done with the A's. Time for the B's. First has 5, then 10, then 4, then 5. So the most I can take out is 4. They all have at least 4. So I need to keep the A's in there. So I need to say 9A to the 3, then B to the 4. And what I would have left is 10A7, only 1 B left, C3, plus 6. I took out 4 B's, so I have 6 left in the second term. None left in the third term, so 6C to the third, plus 9A, 1 B left, and a C. Last letter to look at is C. First has 3, then 1, then 3, then 1. So what they have in common would just be 1. So 9A, 3B, 4C. That's the biggest common factor that they have. That's a pretty big one. Let's see what's left over. 10A, 7BC squared now. Then 6B to the 6, no more C. 6C squared. And 9AB is what we have left. Let me double check to make sure this is okay in standard form. We've got a degree of 10 for the first term, 6, then 2, then 2. So it looks good. That would be our final answer. Last question. A helicopter landing pad or a helipad is sometimes marked with a circle inside a square so that it's visible from the air. What's the area of the shaded region of the helipad at the right? Write your answer in factored form. So the shaded region is the part of the square that's not the circle. So what they're really asking me is for the area of the square and then subtract the area of the circle so that I can get the shaded region. So area for a square is length times width. And since it's a square, we know that both sides, length and width, are going to be 2x. So I need to do 2x times 2x, or 2x squared, for that area. Then I'm going to subtract whatever I get for the area for the circle. That is pi r squared is our area for a circle. So I'm going to do pi, and then r, my radius, is x squared. So first area for the square, 2x times 2x. I'm supposed to multiply 2 times 2 and get 4, and x times x gives me x squared. So 2x squared, 2x times 2x is 4x squared, minus pi x squared. That's my answer, but they want us to factor it. So they want us to see, what do both of these have in common? Let's pull it out front. I have no idea what number 4 and pi have in common. I don't think that there's going to be a whole number they have in common, because pi is a decimal that goes on forever. So I'm not looking for a number in common, I'm looking for letters. They both have x squared in common. So I'm factoring or undistributing x squared, and that would only leave me with 4 for the first part minus pi for the second part. That would be my answer in factored form for this word problem.